And this is going to be for Project 3, the Bluetooth game. And for my game, I actually drew a sketch that will be featured in the actual demo video. But basically, what will happen is there's going to be two walls, one on the right, one on the left, like ping pong. And it's going to be able to, and then the dot will either be able to go up and down using the y axis. And one of those dots randomly will be able to shoot, and if they miss, then the other person gets to shoot. But if they hit, then they get to keep shooting until they miss, and the first person to five wins, and then obviously the other person loses. So pretty simple game, but a relatively interesting mix on ping pong, right? So I think with that, let's start getting into the code. Again, we need our libraries for our Bluetooth devices and our M5 core, along with our Qt controller. And then after this, we need to initialize our UUIDs, which connect them, which again, they need to be the exact same, just like our previous lab and lectures. And then the server sends the entire game state, which is the easiest way I found to do that was through Stack Overflow. And then that client writes its movements and shooting through that one ID, so it's not all clustered onto one ID. So we have three separates there. Then we just initialize our Qt and I2C variables, which we talked about this before. And then our BLE variables, which we also talked about this before. And again, the server is going to actually write the whole game using this one variable and pointer. Again, client writing that joystick movement and shooting through that one variable and using this one variable and pointer. Then we have our screen variables, which again, the fire button is going to be used as the bottom part for the LCD, and then the area of the players that can move inside for that. And then the first thing we kind of wanted to do is to initialize that player and wall variables. So we have our player radius, and then the walls are placed near the far left and right edges. Designed this way again because of similar playing ping pong, or ping ball, whatever you want to call it. And then the players stay next to their own wall, so they can only move up just like ping ball. That's why we will only be starting at the Y positions and never the X. Every time, this will always be true. And then we have our projectile variables, which again, this shows how many pixels will project moving each update, which again, it's always going to be the same speed, which would be 6. And then those variables will keep track of the projectile position and state. And then just an easiest Boolean way to do this is 0 and 1. 0 means you never fired it. Again, not false. And then 1 means you've always fired it, which is true, which again, thanks to Boolean. And so the client will never get confused there. Then we have our score and turn in variables, again, using this 0 and 1, which is very helpful just because if it fires or not, you can just know if it's the server or the client's turn right here. Both of these would be true and true, but it's just easier to use 0 and 1. Again, binary is so super useful to just basically represent true and false, right? And so again, we use it for winning also for both of them. And then again, we use 255 to just mean if the game is going indefinitely. And then also through this, we have the gamepad movement variables, which I created here. And then again, this remembers the previous 8-button state, which will only shoot. And the reason why this exists, so you can never do a multi-fire. So if you could just keep pressing it now, it will only shoot once, and hopefully you get lucky or you're very precise. And then this other one will remember the previous LCD touch state, which again I used from Lab 2. And then through this, we have the BLE game state packet, and this packet basically contains the whole game, so both screens stay synced and no lag occurs, which was a very big requirement on the sheet for the assignment. And then we have our BLE client input packet, which again, this sends its Y location and checks this as whether or not if it wants to shoot. And if it shoots or doesn't, it's up to the player again. So that just checks that. And then after that, we have our on write, which only copies that data to the loop it handles. So the LCD does not crash. And if it will crash, it's sending too much info at the same time. I definitely learned this the hard way because I was trying to do this and all the data was crashing. And it's because I didn't split up what's sending at a time. So have each be a separate variable and then call to that variable. And then we have our BLE client for input, which again, through that, then we have the only copy inside this callback because the drawing or doing the game logic, which again, the BLE callbacks can make the board crash, which again I talked up here about. And then through that we have our connection callbacks, which again we've just copy and paste that from previous Lab 2 and lectures. And then we have our keeping the player up and down in the player, which is using the y-axis. That's why it's called player y. And then we draw the top status of the area. Again, simple, make a black border box, show the screen to the top, which is important. So a comeback can occur when and player can win the game. Yep. So we have the score there. So it's just not like, oh, I hit 5, I won. Like, no, you can see the score. There's always a score in any game you play at an arcade. So as always, there's going to be a score here. And so, yeah, you can see how many you've hit so far. And then after that, it shows the fire button. Again, this is where I created the fire button, which again makes the game super unique. And it makes the button green if it's the server turns, which is a good indicator to go. And gray means you cannot shoot, so it's time to dodge. And then after that, you draw the wall, players, and projectile, which I did here. And through that, so again, if it passes through a game over, then it clears that playing area for projectile and pixels do not get left alive. Very important. Again, I had to look this up thanks to Stack Overflow. And thank you for providing that website also. It's been very helpful for doing these large buckets of code and understanding somehow logic works. Then the servers have to draw the far left wall, which we call that there, and then the client one will draw its far right wall. And then through that server player, which is always going to be blue because I didn't want to make it random which color. It starts getting confusing. So the server will always be blue, the client will always be red, and it's just very distinctive. So if you know you're playing as a server, you know if you're playing as a client. When someone presses that fire, the projectile will shoot now, which again is just an if-else statement. And then after that, it will draw a winner or loser screen, which if it detects a 5, then you're going to get a win. Else, if you're not 5, then you're going to get loser. And then through that, it will tell you first to 5 wins. And then now we copy it and put it into the BLE packet, which again, thank God we have some of the other lecture code to understand how this works. Because you basically just want to just start sending it now over the BLE, and then now you ship it to the client. And then after that, you can start a new game. Again, just use the next lab, and then this actually gets to randomly pick who shoots first when it starts the new game. So it's not unfair in every circumstance. So it's like chess. Except if you don't pick black or white, you either get black or white. So red or blue. And then again, we talked about that before. And then the server shoots towards the right side, makes it simple so it can never be left. And what I meant by writing that comment there is that the server can only shoot right, never left. And so it will either go up and down and shoot right. Just so the logic gets way expansive if you have a multi-directional ways, if you go up, diagonal, all that. So just making it so it can go up and shoot right is way easier. And then, yeah, it just shows the server is fired. And then the client's always left side is so simple, so it's easy to understand. And again, yeah, left side's the same way. And then it checks the projectile if it hits the other player, again, which I just took from the collision. I took the collision logic from Lab 2 and just implemented it here in a little differently and passed through different parameters and used different variables. And then this projectile is aiming for the client, then this projectile is aiming for the server. Pretty simple there. And then if it's hit, detected, it gives a point straight off rip. Which again, if it hits, it immediately puts a point up there. And the server keeps this turn because they got hit. Again, that's what that's supposed to show. And the client keeps this turn because again, they got hit. Client hit, keeps the turn. And then once a miss occurs, this turn goes to the other player and they can shoot now. So when it missed, then it will else kind of basically switch the turns. Then after that, it moves the projectile across the screen so it can hit the other player, just with a big if else statement. And then if the projectile reaches the opposite wall, then it actually misses. And then what the game state does is it actually sends every projectile moving to keep both screens synced so there's no lag, which again, that was very hard. The projectile was super annoying to get working. And then after this, you just need to check the client's movement by shooting a request to see if it's passed. And then after that, again, copy from Lab 2, which is the QT movement. Pretty much the same, except it's just up and down. It's way more movements, one button to shoot. and then we'll read that server movement, and then we'll read the server touchscreen fire button, which once a player fires that button, they should get alerted. Initialize the gamepad QT, which we've talked about before. Same with the BLE server, just took that. And then this actually, again, reads in the whole entire game state and checks if it's active. So that's actually pretty important. And then again, the setup, same, and then you loop it, which is start a game, finishes connecting, and then small wait to just get the client time as normal, restart if it's connected, and then delay it once you start the game. So pretty simple there. And then the other one, player 2, is just the same thing, but I just had Claude put comments here because it's relatively just the same thing, but with the client attacking the server now. So other than that, I think that wraps it up. Yeah, simple, pretty simple idea, but pretty fun just to kick around and just, shoot a projectile at each other, one on the server, one on the client. And it's pretty fair as it picks randomly. So other than that, I think that wraps it up. Thank you.